Yeah. Hello everyone. My name is Nayana R. I'm currently pursuing M.Tech from Reva University. And today I'll be presenting my project titled AI-powered art disease prediction with fuzzy intelligence. So this was done as a part of AI08 batch under the guidance of RACE Reva University. So yeah, let's begin. So we'll move to the next slide. Yeah. The introduction. As we all know, the heart disease continues to be a major cause of death globally. The earlier we detect it, the more lives we can save. However, this is challenging due to many complex medical factors involved. Most traditional machine learning models are accurate, but they often lack interpretability, which means doctor can't always understand how the model reached a decision. So, in this project, I created a smart system that combines a genetic algorithm, random forest, and fuzzy logic. Here, the genetic algorithm means it helps to select only the most important features from the medical dataset. So here, the random forest makes a strong and accurate predictions using these selected features. And coming to the fuzzy logic, it helps the system make decisions that are easier for doctors to interpret, almost like expert rules. We also use a fuzzy Siemens clustering to group patients based on their risk levels, which helps in personalized treatment planning. So yeah, we will go to the next slide, that is a problem statement. So the main challenge we address is that heart disease prediction, like which involves too many medical features which can confuse machine learning models and reduce their accuracy. And we solve this using a genetic algorithm to identify the most relevant features. Then we use the random forest for the prediction, like where the heart disease are more accurately, and and it will make doctors for understandable like what decision they can take. So this is the problem statement we have taken for now, and we'll be moving to the next slide. So slide 4, that is the objective. So the objective of this study are firstly to build an intelligent system that predicts early heart disease early using a patient medical data. The secondly, to improve not only accurate but both accuracy and understandability of prediction using a fuzzy logic. And third, to use a genetic algorithm for selecting the most meaningful features. Fourth, to combine a random forest, fuzzy inference, and fuzzy Siemens for improved explanation and prediction. And finally, to help doctors to make a better and a faster decision using a transparent AI model. So yeah, now we'll be moving to the next slide, that is a data set. So for this project, we have used a UCI data heart disease data set, like which is very known a benchmark data set in this field. So it contains data from a 303 patient records. Like there are like 14 different attributes like age, blood pressure, cholesterol levels, and more. So the data set is balanced in terms of patients with or without heart disease. So it contains both a numeric and categorical data, and there are no missing values here. So making it suitable for the direct analysis. So we'll be moving to the next slide, that is the methodology. So our methodology involves several steps here. So first, we perform a data cleaning and exploratory data analysis, that is EDA what we call. So to understand the patterns in the data set. So next we will apply a genetic algorithm to the most relevant features. Like applying genetic algorithm, we can select a most relevant features. Then above that we can apply a modeling for that particular features. So that's how the genetic algorithm works. So then we then train a random forest model on those features. Right. So after that, we integrate a fuzzy inference system using a human readable rules. So finally, we use a fuzzy Siemens clustering to classify patients into different risk levels. So this multi-step pipeline increases both accuracy and explainability. Yeah. So original implementation. So we have taken a paper like where they have in our original implementation, like they have used a naive Bayes classifier along with a genetic algorithm. So for the pre-processing, so later we improved upon by replacing naive Bayes with a random forest, like which performed better in terms of accuracy, where we were able to get a yeah, we were able to get 82% accuracy. Like when we compare the name whereas what we have got, it was a 79% accuracy. I think it's a great and a good accuracy what we have got, that is 82 accuracy, like after replacing a name bias with a random forest. And I think it like which is performed better in terms of accuracy. And coming to the model improvement, so what we can say is in the updated model, we used the same genetic algorithm for the feature selection and trained the random forest on the selected features. We then compared this a new model with the previous neighbors model and observed the significant improvement in the performance. So as you can see, like I have pasted here the two pictures, like which says the neighbors classifier, it has 79% accuracy, and after replacing a neighbors with the random forest, we were able to see like we add a 82% accuracy, like which has improved, right? So yeah. And then we have also enhanced the model further by integrating the fuzzy Siemens clustering. So firstly, we clustered the imputed data using a FCM. Then we train the random forest on the FCM process data. Finally, we compared the results with earlier model and the further improvement in the accuracy. So this shows the effectiveness of combining machine learning with fuzzy logic and the clustering techniques. So as here we can see, like firstly, we add in a naive bias, like where the accuracy was less, so that was 79%. Then we replace the naive bias with the random forest, where we were able to see the accuracy was 82%. And after using a random forest with FCM, that is a fuzzy Siemens clustering, we were able to see the increase in the accuracy, that is 84%. So that is how we were able to show the effectiveness of combining machine learning with the fuzzy logic and the clustering techniques. So this was how the performance has increased and the accuracy was increased. So finally, we will conclude here like saying this AI-powered system provides a smarter and more transparent way to predict the heart disease, like, which can truly support doctors in their decision-making process. By combining the strength of a genetic algorithm and a random forest and the fuzzy logic, we achieve a good balance of accuracy and interpretability. So yeah, thank you.